Hello everybody, so today we're going to be talking about finding more solutions to different types of systems. So we've looked at linear, and now we're just going to look at different types and see what we have. So I'm going to go through these 4 examples with you just to make sure we understand what we're doing here. So remember, a system just means where do these lines or curves intersect. So let's take a look at A. So with A, hopefully you're looking at that thinking, well, I can do the substitution method here because I can take this and plug it in for y. That's exactly what we want to do. So I have negative 3x minus 1 equals negative 3x plus 5. So now I'm going to add 3x to both sides to get all my x's to one side, and something strange happens. We end up with negative 1 equals 5. So the variable disappeared and we ended up with a false statement. So that means there is no solution. So these two lines never intersect. All right, so let's take a look at B. I think I could squeeze B in right here. So same thing with B, since they both equal y, we can use substitution. I can plug that in. So I'm going to have 2x minus 1 equals 1/2 x squared plus 1. So now I want to get everything to one side, because we're going to have to factor. So whenever we see a quadratic in x squared, we should be thinking, we need to factor this. So I'm going to subtract 2x, and I'm going to add 1. So it's going to give me what? 0 equals 1/2 x squared minus 2x, and then 1 plus 1 is 2. So here we could factor it, but I don't want to. I don't like that 1/2 in front of the x squared. So what I'm going to do is I'm going to multiply everything by 2. That's going to turn that into a 1x squared. So we got 0 equals 1x squared minus 4x plus 4. I'm going to distribute that through. So now it's a lot easier to factor. So now we got what? Two numbers that multiply together to give us 4, but added to be negative 4 are negative 2 and negative 2. So if we go to solve these, and we'd say what? X minus 2 equals 0. We'd add 2 to both sides. And we get x equals 2. And we get the same thing twice. So we'll learn a little bit more about this when we start talking about polynomials, but we know the x value is 2. So now if we want to find the y value, we can go back. And I'm going to use this one because that looks easier. So we'd say y equals 2 times 2 minus 1. Plug in the x value. So that's 4 minus 1 is 3. So we know that these two lines or curves intersect at positive 2, positive 3. All right, so now I'm going to erase everything here. So we're going to take a look at C next. See what we got here. So C is a little different because notice it tells us that y squared equals x. So this is a little bit different, but we could totally take our y squared in here and plug it in for x. So now I'm going to have y equals y squared minus 2. I'm going to get everything to one side, so we're going to factor this. 0 equals y squared minus y minus 2. So we need two numbers that multiply together to give us negative 2, but add to be negative 1. So that'd be a negative 2 and a positive 1. So we'd say what value makes this 0? We could set it equal to 0 and solve it, but hopefully you see that it would be a 2. And what value makes that one 0? Negative 1. So we have two y values here. So now we're going to figure out what our x values are. So I'm going to take that y equals negative 2 and plug it into this. So we got what? So y equals 2, I'm sorry, so we'd say 2 equals x minus 2. So I could add 2 to both sides. And I get x equals 4. So I know our first solution here would be at positive 2, positive 4. So now let's do the negative 1. I'm going to use the same one. So I'm going to say negative 1 equals x minus 2. And I add 2 to both sides. So I get x equals positive 1. So that means this one intersects at 1, comma, negative 1. And that just made me realize this is not right. I put the y first, then the x second. So this order pair should be 4, comma 2. Sorry about that. So we have two intersecting points there. Remember, a quadratic makes a U, so we could have two intersections there. All right, so let's get the eraser out one more time. So the next one here looks like we could do substitution. I'm going to plug all that in for y. So I'm going to plug it all in right there. So I'm going to have 4x minus 2 times 2x minus 5 equals 10. So we're going to have to distribute. So we got 4x minus 4x plus 10 now equals 10. Let's combine our like terms. That adds up to be 0, so we get 10 equals 10. So that means there are infinite solutions. It means these two are the same line. So they're right on top of each other. All right, so hopefully you guys remember back. We're not going to do everything here. I'm just going to talk about this problem. But hopefully you remember back in our transformations unit. That didn't work. Highlight. That is a circle, right? And its center is at the origin, 0, 0, and the radius is 5, right? We take the square root of that number. This is a quadratic that opens up. The vertex is at 0, negative 13. It's been moved down 13 units. So, there you go. So we want to think about how many solutions a circle and a quadratic could have. We just kind of got to draw some pictures here. So notice the first one here could be none. The circle could be not crossing the quadratic at all. This is a 1 solution. You can see it touches at the very top. So this one would be 2 solutions because we can see it crosses twice. This one would have 3. And this one would be 4. It's a pretty bad drawing, but you get the picture. So we could have 0, 1, 2, 3, or 4 solutions here. So that's something else we have to think about is, what kind of shape does our function make and how many times could it possibly cross? All right, so we're going to talk about a couple of different types of systems as well, but we are going to focus on, for your guys' practice, linear systems. But we need to be able to solve word problems. So we're going to take a look at this one here. So you got a job. So job A offers a starting salary of $52,000 a year with an increase of $3,000 per year. And job B starts at $36,000 with an 11% raise. So we want to figure out, when is job A a better situation? When is job B? Kind of think about this for a minute and make a decision on what job you would want to take. So we need to be able to represent these with some sort of equation. So job A, to me, it looks like it's linear, right? Because we have a starting point, the y-intercept, and then our slope. So our starting point would be the 52,000, and our slope's 3,000 per year. So we could represent this to be y equals 3,000 x plus 52,000. So if we want to know how much we make after 10 years at this job, we plug in a 10 for x and see what we get. So job B is saying we get a raise of 11% a year. So this is an exponential growth problem. So what we'd want to do here is have what y equals, we have our starting point, 36,000. And then since it's a growth problem, we would say, 1 plus 0.11 for our percentage, so it'd be 1.11. There we go. And our exponent would be to the x minus 1. All right. And that way we could represent that one. So obviously, I think you guys can see the job B starts off way less, so I think the easiest way to solve this problem would be to look at it in a calculator. And that's what we are going to do. All right, so the x is representing the number of years you've worked, and the y is representing how much money you make. So notice I set my window up to be 0 to 35. So we'll say we'll probably work about 35 years before we retire. Just trying to get a whole picture here. Now, our y min and y max, we need to adjust those as well. So we should maybe we could start that at about 36,000, right? Because that's the first year, how much you make in the first year of job B. And our y max, we really don't have a good idea because we haven't plugged in anything. So we could just take a guess. Let's say 500,000. See if either one of these jobs will make 500,000 after 35 years. Might be surprised. So now we're going to go back and type in our equation. So our blue line is going to be the linear, 3,000 x plus the starting value, 52,000. And the red one will be the job B that starts at 36,000. And we get an 11% raise each year. All right, so hopefully you have an idea in your head what's going to look like. Let's graph it. There's job A and there's job B. So we can see that after a few years, job B increases way, way faster. And actually, we're already over $500,000 right here. So let's find out where that intersection point is there. So we could set these guys equal to each other and work it out by hand, or we could use our graphing technology. So I'm going to take the calculator out. I'm going to hit second, and then trace. That'll take me to the calc option. And I'm going to find intersect, the fifth option. So notice it says first curve, so I just press enter. Notice it's in blue. It'll jump to red. Now it's on the second curve. I press enter. Now my guess, I'm going to move it to where it looks like it's intersecting as close as I can get it. And let the calculator do the work. And press enter one last time. So we can see right there. It's about 8.3 years. The jobs will be paying the same amount. So after year 8, basically, job B would be a much better offer. And notice how much it grows compared to job A. So hopefully you chose job B. So my last question would be, well, let's say we work 30 years. How much would we make at job A and job B? So we could plug in 30 to each one of the equations if we wanted to and work it out by hand. But if we got a calculator, we can go to our table and look. So I'm going to hit second, graph. That'll take me to the table option. And then I can kind of just scroll through this and see what we got. You could type it in if you wanted to. But I'm just going to go down to 30 and see what we have. So after 30 years, job A would be paying $142,000. After 30 years, job B would be paying $742,000. So hopefully you see the job B is a much better option. All right, so we should be able to solve systems that aren't linear, using the calculator or by hand. It's kind of up to you guys. So let's flip back here. Let's look at a linear system. So our math class is going to collect money for a field trip. Right, we can't be in school, so we're definitely not going to be on a field trip, right? So we're going to sell two bags of candy. We got the chocolate lovers bag, which is $4.25 for 5 chocolate truffles, and 2 caramel turtle candies, and then the combusting caramel bag. Sounds disgusting. It's $3.50 for 8 caramel turtle candies and 2 chocolate truffles. So we got to figure out how much they cost. All right, so let's set up what we have here. So what are our variables? Well, let's say X is the cost of chocolate truffles. I'm going to be lazy and put a $sign. I'm going to put chocolate truffles, so the cost of a chocolate truffle. Well, then our Y would have to be the cost of the caramel candies, so the caramel turtle candies. So now we need to set up our equations. So the chocolate lovers bag is 5 chocolate truffles, so 5x, and 2 caramel turtles, 2y, equals 425. And then the combusting caramel bag is $3.50 for 8 caramel turtles and 2 chocolate truffles. So I'm going to put 2 chocolate truffles, 8 caramel ones, all for $3.50. So now, notice this one is set up to where it looks like we could use elimination. I think that's going to be the easiest route. So we need to look at these two equations and say, well, if we add or subtract them, will one of the variables disappear? No. But notice, if we multiply the first one by a 4, we'll be able to subtract them because then we would have an 8y minus 8y. So that's what I'm going to do. So I'm going to distribute this through. And distribute through, and distribute it through. There we go. Let me fix the thickness of my pen. There we go. So now we're going to cross that one out, and we're going to say let's subtract these guys because this should help us find out what they cost. So we got 2x minus 20x. That's negative. 18x. 8y minus 8y is 0. So now we have 350 minus 17. So we're going to have a negative value there. So would that be negative 1350, right? So now, last step, divide both sides by a negative 18. So we divide that and we get x equals 0.75. So that's telling us that our chocolate truffles cost 75 cents a piece. So now if we want to find out what the other one costs, we just pick either one of the equations and we're going to plug that back in. So I'm going to go with the second equation. Doesn't matter which one you pick, but so I'm going to have 2 times the 0.75 plus 8y equals 350. So 2 times 0.75 would be $1.5, $1.50, plus 8y equals 350. So now we need to subtract $1.50 from both sides. So we've got 8y equals $2, right? 2. So we divide everything by 8, and that'll give us y equals 0.25. So now we know that our chocolate turtles are 75 cents and our caramel turtle candy is 25 cents. So these are the type of problems that we really need to focus on and make sure we can do. So the linear systems, and that's what your homework's going to be about.